Good day everyone, I am Marie Theresa Montas from BS Chem 2H1 and in this video, I will be talking about gasification of volumetric titrimetry and some example of it. But before that, let's have some words of volumetric titrimetry first. Well, it is a type of titrimetry in which the standard reagent is measured volumetrically. It establishes a quantity of analyte using volume of reagents of known concentration and the knowledge of stoichiometry of the reactions between reagents and the analytes. Now for the classification of volumetric titrimetry, acid-base being the first, whose analyte is both inorganic and organic that are either acids or bases. Its titrant, a standard solution of a strong base or a strong acid, and pH meter as the indicator. Here, we will consider titrations that involve acid-base reactions. In a titration, one reagent has a known concentration or amount, while the other reagent has an unknown. Typically, the known reagent, the titrant, is added to the unknown quantity and is dissolved in solution. The unknown amount of substance, which is the analyte, may or may not be dissolved in solution, but usually is. Then the titrant is added to the analyte using precisely calibrated volumetric delivery tube. For example, suppose 25.66 ml of 0.10 mole hydrochloric acid was used to titrate an unknown sample of sodium hydroxide. From that being said, we are then to get the mass of sodium hydroxide that was in the sample and calculate the number of moles hydrochloric acid reacted. That type of calculation is performed as part of a titration. And some more examples are acid content in wine, milk, and ketchup. Content of inorganic acid like sulfuric acid. The second classification of volumetric titrimetry is the precipitation. In precipitation titration, the titrant reacts with analyte and forms an insoluble substance called precipitate. It continues till the last amount of analyte is consumed, the titrant. Example: to determine the concentration of chloride ion in a certain solution, we can titrate this solution with sulfur nitrite whose concentration is known. Some more examples are the following: salt content in crisps, ketchup and food, silver content in coins, sulfate content in mineral water, and sulfate content in electroplating bath. The third classification of volumetric titrimetry is the complexometric. The titrant, which is a chelating agent, forms a water-soluble colored complex with the analyte, a metal ion. Complexometric titrations are based on the formation of a complex between the analyte and titrant. Ethylene diamine tetraacetic acid is one of the most common chelating agents used to titrate metal ions in solution. Complexometric indicators are water-soluble organic molecules. Some examples are calcine with ethylene diamine tetraacetic acid for calcium, Paton reader indicator with ethylene diamine tetraacetic acid for calcium with magnesium. Now, for the fourth classification of volumetric titrimetry, reduction oxidation, it involves the titration of an oxidizing agent with a reducing agent or vice versa. An oxidizing agent gains electron and a reducing agent loses electrons in a reaction between them. There must be a sufficiently large difference between oxidizing and reducing capabilities of these agents for the reaction to go to completion and give a sharp endpoint. That is, one should be fairly strong oxidizing agent and the other fairly strong reducing agent. The tarnishing of silver is just one example of broad gas of oxidation-reduction reactions that fall under general heading of corrosion. Another example is the series reaction that occur when iron or steel rust. When heated, iron reacts with oxygen to form mixture of iron and iron oxides.